This is FRQ 6 of the 2025 AP Calc BC exam. So they give us this Taylor series for a function f about x equals 4, and in part A, they want us to use the ratio test to find this interval of convergence. If you remember, the ratio test is just the limit as n goes to infinity of the n plus 1th term over the nth term. Here we have the n plus 1th term over the nth term. This can be rewritten like this, and here we can cancel a lot of things out, like the x minus 4 to the n plus 1s and the 3 to the n's. We can also take this x minus 4 and factor it outside the limit because this limit is in terms of n, not x. So we have the absolute value of x minus 4 times the limit of n plus 1 over 3 times n plus 2, which we know is 1/3. We have the result of the ratio test to be 1/3 absolute value of x minus 4, and we want this to be less than 1. Which means 1/3 x minus 4 has to be between -1 and +1, which means x must be between 1 and 7. Now we found our interval of convergence, we just have to see if we can include these endpoints. If we plug in x equals 1, we have this series, which simplifies to this alternating series, and it can be shown with the alternating series test that this series converges, so we can include 1 in our interval. But if x equals 7, then we have this series, which reduces to this, and this is a harmonic series which diverges, so we can't include 7 in our interval. This right here is the interval of convergence for part A. For part B, they want us to find the first 3 non-zero terms and the general term for this Taylor series of f prime. So if this is the series for f, then we need to find this, the derivative of the Taylor series for f. Since differentiation and summation are both linear processes, I can switch their order so we differentiate first and then sum. And we differentiate this just like any other function. We multiply by this exponent and drop the exponent by 1, which gives us this series. With this rule, these are the first 3 terms. This is the general term. Now in part C, they want us to show that the f prime series converges to x minus 4 over 7 minus x for all x in the interval of convergence. This is what we found in part B. And if we rewrite it like this, we can clearly see that this is a geometric series with common ratio x minus 4 over 3. Geometric series are special because they're one of the few series you can actually find the sum of. Remember, the sum of a geometric series is the first term over 1 minus the common ratio. Here, our first term is when we plug in 1, so it's x minus 4 over 3. And our common ratio is also x minus 4 over 3. From here, it's pretty easy to see that this simplifies to x minus 4 over 7 minus x. Part D, they tell us that the radius of convergence for the Taylor series about f is the same as the radius of convergence for the Taylor series of f prime. And then they want to know if the Taylor series for f prime converges to this at x equals 8. If the radius of convergence is the same for both series about x equals 4, that means both series have the same interval of convergence. And we saw in part A that the interval of convergence for f is 1 to 7. The radius of convergence for f prime is also 1 to 7, and since 8 is outside that, the answer here is no. That's the 2025 AP Calc BC exam. Be sure to let me know if I made any mistakes in the comments, and check out the rest of my page for the other FRQs.